Hello together. In this video, we will have a closer look on the diagnostic topic at Ethernet IP with our API system. We have in total 5 possibilities to get diagnostic. The first would be the web server, second would be explicit messaging, third status and diagnostic assembly, the fourth is the diagnostic add-on instruction, and the last would be the L5X import diagnostic information. We are starting now with the web server. Therefore, I'm just opening the web server. You see it here. The web server is already running. And you see now my system. And the only thing to get diagnostic in the web server is to provoke an error. And I provoke now just an error. And you will recognize in a few seconds the error will be shown directly in the web server. In this case, I have created an load supply problem. I have switched it off the load supply, and the API modules which need the load supply to work have a warning now. You see here, this is directly happening in the web server. I can now put it back and the web server is updated automatically. Very important, we are using here in my project the version 1.3.1. This is the latest version. If you don't have it, go on the support portal and make an upgrade, then you have the same look and feel like I. Okay, that was the web server AP field where you are getting directly the information. What else do I have here? I have here at the system the diagnosis. And then the diagnosis is nothing else as the diagnostic trace object 66. And in this trace, we are seeing all the things what were going on inside our node. You see here, we had the undervoltage load supply and so on. And these are some kind of diagnostic history. And if I now provoke another error, you see here, the diagnostic trace will be updated and has now, in this case, an overload on the sensor, and then the case is solved and the overload on the sensor is gone. For you, just an information. Here in the diagnostic trace, you see active messages 2. They are highlighted here with this blue color or the red. If a message is not activated anymore, then it is like this. Everything is grayed out. What else is very important is to know that the diagnostic trace is not remnant stored inside the node. That means as soon as I'm making a power off on of the system, the diagnostic trace is empty again. You see here now we are starting up. Now we are in run mode, no trace information. This you have to keep in mind. This is not a remnant trace. Now the next thing will be explicit messaging as diagnostic possibilities. To use explicit messaging, we need a programming code and we need to know the object class, the instance, the attribute. In the menu, you see here the diagnostic object 65 and the instances 1 till ... are the number of modules. Here we are speaking about instance 0. This is the 0 instance, and this here belongs to the instances of the modules. You see here in the instance of a module, the 1, that you are getting the module diagnostic status. This module diagnostic status includes a bit 0, which says the communication is okay. That means you have a communication via the AP cable to the module. Furthermore, if you If you scroll down, you see here also the diagnostic code. This is the diagnostic code, the 4-byte message which our system is sending out and is available on each module which has a problem. Knowing these two things, I can go back here in my logics, and you see here, I have here in the main program the main routine, and here I am jumping now to the API diagnostic. In the API diagnostic, you see here, I have created for each module a message instruction. And if we start here with the state of the module, you see here, I'm making here this toggle bit. You see here how I have done it. I say get attribute single, the class was 65, the instance 1 is module 1, and the attribute 1 is the module state. And then I'm saving everything in a tag for the module state, which has 4 bytes. Communication is done directly to the module. You see it here. This is our module. And this is now the state of the module 1. And I have done this for all the modules which are available. In total, I have at the moment 7 modules, as you see it here. It means 7 times I'm doing this. And if you go to state module 7, you see here, I just changed the instance to 7, and the rest was equal. And of course, here I'm using now the state for module 7, another variable. The tag, etc. is the same. Here in the second one, I'm looking just for the error codes. Going inside, you see here the same principle. Error code module 1, the class is 65, the instance for module 1 is 1, the attribute for the error code was based on the manual 4. So this is the same path, everything is looking good. 7 times I have done this, and you see here instance 7. This is really a short program to check if the module is available and what kind of error code is at the moment appearing. Of course, you have a lot of more possibilities if you have a closer look inside the menu. You see here that we're getting a lot of other informations too. In the object 65, we have here also the trace object, which is the one what I have shown in the web server. Here it is also available. This is a buffer with 512 entries maximum. But as you know, as soon as you make a power off on cycle, this buffer will be empty. But it is also here available. With this object, you are getting all the messages via explicit messaging directly by the node. And we're testing it now. I am creating an error. Disconnecting again. You see here the system is flashing. Then let us first check the diagnosis state, toggle bit. Everything is fine. Then we're going here to our controller text and see what is the message. The state of the module is, wait a second, go down. Diagnosis state of the module is now 5. If we have a closer look inside, the bit 0 says, okay, the module is available. And we have here 0, 1. If we go to the menu, then we will recognize 0, 1. Okay, it is a voltage problem. Okay, diagnosis state is showing me this. If I'm going now to the error code, the error code of module 1 is not executed till now. My mistake. I'm executing it now. And then I'm getting also the module code. And I'm seeing here everything is fine. This is exactly the message if you go in the manual for load supply is missing. Good. Now we want to make an interruption of the bus. Therefore, I'm just disconnecting here the cable. You see now I have disconnected the cable. Everything is disconnected. The last module is vanished. From my bus, if I go now again to my API diagnostic and I say here toggle bit again, then I'm realizing now in my controller tags that the state of the last module is 0. That means here the module is not available compared to the state of the module before. You see here, okay, I still have the under voltage problem, but the module is available here. This is the state. It is for you a possibility to check if you are losing a module during operation, maybe by a cable interruption or some other problems. To integrate the module, we have again to put the cable back. I'm now making back the load supply. This is not a must, but I'm doing it that I have no error anymore. And you see here, it is still red. And in the manual is described, normally it's a power off on necessary to do this, but you can do this also by programming code. Therefore, I have here in the main routine something very simple written without any checking of is it really possible, etc. It is just a stupid logic where I'm doing here an inhibit of the API system. If you go here to the inhibit of the API system, I just inhibit the node, toggle bit. Now the node is inhibit. You are recognizing it on the NS LED, which is now flashing. And then I bring it back to my bus. You see it also here, it is inhibit. And now I bring it back to my bus. And then everything is running. This is the workaround for a power cycle, which I can do as recommended alternative from the manual.